In this video, we're going to talk about data analysis for third grade. There are two data analysis TEKs that we're going to talk about, and it's 3.8a, which is our readiness standard, and 3.8b, which is our supporting standard. 3.8a is asking us to summarize data with multiple categories using a frequency table, dot plot, pictograph, or a bar graph with scaled intervals. Then, once we've summarized that data with graphs, we then have to solve 1- and 2-step problems using the data represented in those tables and graphs. Okay. You can see here that students have a lot of knowledge of data analysis. They have been doing data analysis since kindergarten. They collected, sorted, and organized data. They created real object and picture graphs, and they've been drawing conclusions and answering questions about data since kindergarten. Okay. First grade did the same thing, but in first grade they started doing tally marks and T-charts, and they created pictograph and bar type graphs. And then in second grade, they continued their pictographs, and then they did bar graphs with intervals of 1 or more. And something else they did in second grade was they wrote 1-step problems they could solve using their graphs. Okay, so as mentioned, this year we are going to be looking at data and summarizing it using a frequency table, a bar graph, pictograph, or a dot plot. Okay, so the first one we can talk about is a frequency table. This itself is a frequency table, and so in order to start with a frequency table, because we have pictographs and frequency tables, first I would have the students have a bag of color tiles, have different colored M&Ms, different colored Skittles, different colored crayons, whatever it is, where they reach in, pull it out, and they can create this type of frequency table where they're drawing their tally marks, and then they can actually take it and make it more concrete. Okay, so as I said, you could have them doing color tiles, because we know the color tiles are red, green, yellow, and blue. And as they're pulling them out of a bag, students could be tallying what they're getting, right? And so forth. And then from there, students are going to create that frequency table, the other type, where it talks about color of Skittle, number, right? And they're going to do their red with 5, their green with 1, their yellow with 2, and their blue with 3. Then from there, they can create pictographs of the information that is in the table. Okay, so let's talk about a pictograph for a minute. Pictographs, this last STAR test we had, the 2017 STAR test, pictographs were the most missed problem on the test. So I wanted to talk about a pictograph and talk about the strategy for a pictograph. And it says the graph below shows the number of pounds of plastic the Keller family recycled for 5 months. So before I even get to the question, I want to make sure that I understand what the graph data is showing me. Okay? So in a pictograph, the most important thing is the key. So as a strategy, my graph is talking about recycled plastic. I find my key, I circle it. If I have a highlighter, I highlight it, I point to it, I star it, whatever I need to do to show that I know that key. Each barrel or I can say cylinder here, so it's a cylinder, means 20 pounds. So what would half a barrel be? Half. If one is a whole, what is half? It would be 10 pounds. You have to model for this for kids all the time, and you have to have them do this. So then I go to the graph. This is a half, so I know that's 10. A whole, 20, 20. 20, 20, 20, 20, 10, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, I know I can sound like a broken record, 20, 20, 20, 20, 20, 20, 20, and then I can count each of the bars, 20, 40, 50, 20, 40, 60, 80, 20, 40, 60, 81, 120, 130, 20, 40, 60, 81, 120, 20, 40, 60, 81, 120, 140. Now, I have done all of that without even looking at the question because I want students to understand the data in my graph first. So I know March, they collected 50 pounds, or they recycled 50 pounds. April, 80, May, 130, June, 120, and July, 140. So then I can go to the question which says, based on the graph, how many more pounds of plastic did the family recycle in July than in April? So here's July, 140, and I am comparing that to April, which is 80. Okay, how many more pounds? So I'm looking for this. So I could then do my 140 minus 80 and get my answer. Make sure students are doing this exact strategy on these pictograph problems. As I said, #1 most missed question on 2017 STAR. Okay? All right, so once we've done frequency table and pictograph, we move into bar graphs. Now, once again, you can continue on with those frequency tables because the frequency table is how you get your data. Then you're going to represent it with a bar graph. Okay, so let me find a bar graph question. All right, it says, the graph below shows the number of miles Lincoln rode his bike during 6 weeks. Once again, I am going to go directly to the graph. So, because I want to understand the graph information first before I even look at what it's asking me. So bike rides, this is the amount of bike rides he rode for 6 weeks. Okay, here's the weeks. Oh, look at this one. Usually one's on the bottom. They did one on the top. So 1, 2, 3, 4, 5, 6 weeks. 0, 12, 24, 36, 48 are my number of miles. But there's a line in between 0 and 12, and a line in between 12 and 24, and a line in between 24 and 36, and a line in between 36 and 48. So we have to get kids automatically thinking about, okay, so that means this line is in between 0 and 12. So what is in between 0 and 12? It is 6. So this graph is going up by 6. So I have 12. What's 12 plus 6? 18. What's 24 plus 6? 30. What's 36 plus 6? 42. Okay? So now I can go label my bars. So this one is for week 1, he rode 36 miles. For week 2, he rode 18. For week 3, he rode 42. For week 4, he rode 30. For week 5, he rode 48. Week 6, he rode 42. Okay, so I know right there how many miles he rode each week, right? I've done it with the graph. Which table represents the information in the bar graph? So let's go to week 1. Week 136. Week 136. Week 136. Week 136. All these frequency tables show me the same information for week 1. Week 2 is 18. This shows 14. That cannot be it. Week 2 is 18. Oh, this one shows 24 for week 2. That's not it. Week 2 is 18. Week 3 is 42. Week 3, 42. Week 3, 42. Week 4 is 30. 30. Week 4 is 30. 30. So we're good so far. Week 5 is 48. Here it has week 5 as 42. So that can't be it. Week 5 is 48. And week 6 is 42. So this is my answer. Okay. Your students' work for graphs needs to look like this. They analyze the graph first, and then they go on to the question and determine what the question wants them to do with the data in the graph. Okay. All right, so finally, the last type of graph students are going to learn about is the dot plot. Okay. So the dot plot has dots which represent the data, okay, instead of a bar, instead of a picture. So it says the frequency table shows the results of a survey about how many days per week some families eat dessert, okay? Now, I'm going to stop right here because although this is the frequency table, this is where my data is housed, right? So I'm going to stop right here and understand my data. So for day 1, instead of these 2 lines, I'm going to go ahead and write 2. For day 2 is 4. For day 1, I'm sorry. Day 2 is 5, 6, 7, 8. Day 3 is 5, 6, 7. Day 4 is 3. Day 5 is 4. Day 6 is 1. And day 7 is 1. Okay, so now I understand my data. So how many days a week do some families eat dessert? Okay, so it says which dot plot represents the data in the table. I have got to label each one of these. Yes, it takes time, but I've got to label them. If you want to give students a strategy where they don't have to label everything on each one, you can do it this way. You can say, okay, boys and girls, let's see. So there's 0 dots above 0 in A. How many people said they eat dessert 0 times? 2. So I should have 2 dots above 0, and I don't in this one. I do here. I do here, and I do here. Okay, so those 3 are good. I should have 4 dots underneath or above 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. I should have 8 dots above 2. 1, 2, 3, 4, 5, 6, 7. That looks like 7 to me. I'm going to recount just to make sure I didn't mess up. 1, 2, 3, 4, 5, 6, 7. That can't be it. 1, 2, 3, 4, 5, 6, 7. Oh, that can't be it. 1, 2, 3, 4, 5, 6, 7, 8. That can be it. So look, I only have 1 graph left, but I'm a smart mathematician, and I'm going to check. I should have 7 dots above 3. 1, 2, 3, 4, 5, 6, 7. I should have 3 dots above 4. 1, 2, 3. I should have 4 dots above 5. I do. I should have 1 dot above 6 and 1 dot above 7. So this one's my answer. Okay, as I said, with graphs, it is about students understanding the graph, the information, the data they're given, and then either answering the question based on the graph or representing the data in another way. Okay? All right. So those are the three types of graphs, but 4 types of way data are represented in 3rd grade. Please let me know if you have any questions.